Hi guys, and welcome to another video. Today we will show you the Hieha DP-X 3D printer. This printer is sold as a kit, and in this video we will do the detail assembly and share with you the first prints. The printer has a nice printing volume of 300 by 300 by 400 millimeters. But first, let's do the unboxing.
Hey you guys! So, let's check this printer out. Inside the box, we can find the print surface. We also find the CE documentation, the aluminum heat bed, the Y-axis carriage, a USB cable, the power cord, the X-axis MGN linear rail, the PTFE tube, some zip ties, the right Z carriage, the left Z carriage complete with the extruder motor, end stop and filament sensor, the hot end assembly, the Y-axis motor, memory card and memory card reader, a bag with spare parts, which also includes some nozzles, some rubber strips, motor cables, a spool with PLA filament, a Z stepper motor, the second Z stepper motor, the top lead screw bearings and belts, cable wrap, an Allen key, the spool holder parts, and the bag with more tools. One more piece of the spool holder, and these are the backside feet of the printer. Some 20 by 20 metal profiles, a few rods and lead screws, A few more metal profiles. These are 40 by 20. A bag containing many smaller bags with screws. More 40 by 20 metal profiles. And finally, the structure that contains the display, power supply, and the board. And these are all the parts. Before starting the assembly, let's check the electronics in more detail. The board seems to be a custom-made 32-bit board. It's equipped with 4 non-replaceable HR4982 drivers. On the back side, we see the SKR Mini V2.0. The display is a 3.5-inch color touchscreen, and the power supply is a 24-volt 15-amp model. The DC connections don't have any ferrules on the power supply side and also on the board side. And for that reason, we took care of this detail first, and we crimped terminals and ferrules for a safer connection. The heatbed power wires also don't have any ferrules, so we changed that too. And we did the same with the hot and heater wires. To start the assembly, we need the bag of screws labeled with the number 1. Next, we need to identify the bottom 40 by 20 profiles. The ones that we need for this step are the ones that have all these holes, and the screw slots need to be facing down. We also need the bottom 20 by 20 metal profiles. These ones have holes in the middle. Next, we need to align the profiles so that the screw slots are facing outwards. For this step, we need the M5 by 20 mm screws. Before moving to the next step, make sure that the frame is squared. Next, get the rod support mounts and the rods. The rods must be inserted in the support mounts. Before installing the support mounts on the opposite end of the rods, we need to pass the rods in the linear bearings that are already installed on the Y-axis carriage. Now we can install the Y-X assembly on the bottom frame. And to secure it, we need the M5 by 16 mm screws. Confirm that the distance between the two rods is the same on both sides. And then secure the bearings. The holes on the 40 by 20 profiles are not at the center, so we need to make sure that the shortest distance will be on the back side of the printer, and at the front side we install the electronics. There are 4 bolts with T-nuts that we need to align the profiles onto. And to tighten these bolts, we need to flip it on its side. Next, we grab these U-shaped parts. These will be the back feet of the printer. For this step, you need the Y-axis pulley and one M5 by 16 mm screw. You need to disassemble the idler first to install it on the frame. There is a tapped hole in the middle of the front 20 by 20 profile, and there is where you need to install the idler. Next, we will install the Y-axis motor. The back 20 by 20 profile also has a tapped hole, and we will need to use it to help align the motor. To tighten this M5 by 16 mm screw, it's better if you use an Allen key with a round tip. This way, you don't need to remove the motor gear. For this next step, we need to take one of the belts from the bag. Secure the belt under the Y-axis carriage. Make sure you have teeth with teeth and secure it with a couple of zip ties. Next, pass the belt around the idler and then around the Y-axis motor gear. Finally, secure it again with teeth and with a couple of zip ties. Make sure you have the belt with the correct tension. From bag with label number 4, take 4 M5 by 20 mm screws. They will be used to secure the vertical profiles. These vertical profiles must be installed with the 2 side holes close to the bottom frame. The 2 Z stepper motors are installed at the back of the vertical profiles, and the tapped holes are used to secure the motors with some M5 by 20 mm screws. Next are the couplings. Find the flat area of the motor shaft and tighten one of the coupling set screws there. Don't forget to tighten also the second set screw. Do the same procedure for the other coupling. In the meantime, we noticed that the Z motors were not aligned with the vertical profile. This is because the stepper motor mounts are not correctly bent with 90 degrees, so we had to remove them and fix that 90 degrees curve. Next are the Z-axis carriages. It's a bit odd that they use wheels but don't use any eccentric nuts to adjust the grip. So, if you need to make adjustments to the grip, you need to loosen the bolts, force them, and tighten them back. Now, slide down the right Z carriage and the left Z carriage. This is how it looks when viewed from the back side. Next, grab the lead screws and install them. Tighten the coupling set screws. Get the last screw bag and install the top horizontal profile. Again, make sure the screw slots are facing up. Secure the top profile with M5 by 20 mm screws. Measure the distance between the vertical profiles at the bottom and at the top. If the distances don't match, adjust the top profile. Get the MGN rail and 4 and 3 by 8 mm screws and secure the rail on the Z carriages. Before tightening the screws, measure the distance from the bottom profile to the rail and adjust so that they are at the same distance. And then tighten the screws. The hot end heatsink has two holes. This might indicate that the second one is for installing an auto level sensor, but it's not included. The PTFE tube on this one goes all the way down to the nozzle. There are 4 holes at the back of the hot end assembly to secure it, but we need to disassemble it to be able to secure it. And to do that, we need to remove these 4 screws. Now we get the back plate and secure it to the linear rail. For cooling the hot end heatsink, they used a powerful 40 by 20 mm fan. Place all the parts in order and install them back to the back plate. Next, install the pneumatic fitting on top of the heatsink. Before installing the PTFE tube, make a clean and 90 degrees cut on one end of the tube, and then get a Sharpie and make a mark 6.3 mm from the tip. Insert the PTFE tube all the way in and confirm it with the mark. The other end, insert it in the extruder. Get the second belt and secure it on the X-axis carriage. Make sure you get teeth with teeth again. Pass the belt around the idler and behind the X carriage, around the motor gear, and finally secure it on the X carriage. Also, make sure to secure the belt while keeping the belt with tension, because there is no other way to tension the belt afterwards. Now get the lead screw top bearings. These will be installed on the top metal profile. Place the T-nuts first and install the top bearing. Align the T-nuts and tighten the screws. If you detect any slight bend on the lead screws, we recommend not to install these top bearings, as it will be better to work without them. And now we can install the heat bed. Place the screws and the springs. and then secure them with the nuts. Get the provided cable wrap and use it to protect and guide the cables. The hot end cables can go through the left Z carriage. Now, we just need to make all the electrical connections. Connect the heatbed power wires and the heatbed temperature sensor cable. The Y-axis end stop is connected to the -Y connector. Connect the Y-axis stepper motor cable, and for the Z stepper motor connection, you get a parallel cable to connect both motors. Connect the X-axis motor cable and the extruder motor cable. Connect the Z end stop and the X-axis end stop. Connect the filament sensor cable. Connect the heatsink fan and the layer cooling fan. Connect the hot end temperature sensor and connect the hot end heater wires. And finally, connect both Z stepper motors. The heatbed cables must pass through the back left foot, because this way you have a good cable motion. The manufacturer did not make any strain relief for this cable, and this is something to be worried about because the cable will suffer from fatigue soon enough. So a strain relief system must be designed and installed as soon as possible. All the cables can be secured nicely with zip ties along the profiles. And since there is no driver cooling fan, the cables must be secured away from the drivers. The big M5 by 45mm screw is installed on the left profile. This screw is used to trigger the Z end stop. The spool holder is very easy to assemble and install. It should be installed on the back left side of the printer. We ended on not using the rubber strips as we felt that they were not needed. Last but not least is the print surface that you need to glue on the aluminum plate. And the assembly is now complete. Before turning on the printer, we recommend to add grease on all the axes. and then move all the axes manually to spread the grease. Connect the power cord and turn on the printer. In the menu and clicking on the About button, we can see a nice picture of the printer. One of the coolest things we found in this firmware are the temperature graphics. We enter the bed preheat menu and type in the temperature we need and then turn on the heater, and we see the graphic of the temperature variation along the time. For the hot end, we need to enter the unload menu, type in the temperature we need, and turn on the heater to see the same graphic. In the print menu, we have a clear view of all the files stored in the memory card and their names. The slider makes it easy to navigate through the files. In the manual menu, we can move the axes back and forth, and we can home each axis or all of them at once. The first thing we need to do is to adjust the Z end stop. So we need to manually lower the Z by rotating both couplings at the same time until the nozzle touches the bed. And then we adjust the screw until it triggers the end stop switch. And next, we home the axis. Then we level the bed using the leveling option on the display menu. For leveling, we use a 0.1 mm thick piece of paper. The bed leveling procedure is not that easy because the leveling nuts are too small. We recommend to replace these small ones with bigger ones. The dots on the leveling screen also don't match the actual coordinates of the printer, but that's not a big issue. Now it's time to test the printer. So let's insert some filament and run some prints. The first one we tested is an already sliced model that was included in the memory card. And then we sliced other models with our own profile. We also tested the filament runout detection and power resume feature, and they worked as expected. One thing we noticed when removing the filament was that it got stuck every time, and we had to take the PTFE tube out and cut the tip of the filament. This is because the internal hole diameter of the fitting is too small, and the small variation of the filament after heating up gets jammed. The fix is very easy. We used a 2.2mm drill bit to increase the hole diameter a bit, and that was it. No more jams. And these are the test prints that we have made. The first one is the small bunny. This one was the already sliced model that was included in the memory card. We can see some over-extrusion on the layer changed spots. We also see some issues with hanging, which are related with cooling. In fact, the fan duct design could be a little bit better since you have a big output of air but is not centered with the nozzle. Next, we printed an articulate cat, and the result was very good. We also printed this elephant, and we can see the very smooth layers and an impeccable first layer, but a lot of salmon skin. This small unicorn is another example of that. Very good detail and nice layers, but lots of salmon skin. And finally, we printed this tall vase in vase mode. And once again, the result is also good. In conclusion, we feel that this printer can print very good and gives pretty good results, except for the salmon skin. If we replace the main board with a different one and with better drivers, the printer will be capable of producing better prints. However, it's critical that you inspect both Z-motor support mount plates before installing them, because if they are not at 90 degrees, you will have problems with the lead screw alignment. And that's it, you guys. Thanks for watching. As always, if you like our work and wish to help the channel, you can with Patreon or PayPal. You can also help the channel with the affiliate links that we provide in the video description. As always, keep following us here on YouTube, Facebook, Instagram, and Twitter. We will see you guys next time. Bye!